In this final week of the course Designing a Climate-Neutral World, we will discuss in greater detail how greenhouse gas emissions can be reduced. We will focus particularly on energy efficiency and renewable energy, as these are major options to achieve a climate-neutral energy system. So, in this video we will start with discussing energy efficiency. You may remember this picture that I showed you in the very first week of the course. In all mitigation scenarios, energy efficiency plays a central role. It is the first step to achieve far-reaching emission reductions. But what actually is energy efficiency? Efficiency is about doing or producing things without wasting materials, times or energy. It is simply a ratio of total input to useful output. In our context, we are primarily concerned with the efficiency in terms of energy. The output can be either some form of energy or it can be something else useful. Therefore, we make a distinction between different types of efficiency in the energy system. For end use, we can look at the end use efficiency, the efficiency of the different final applications of energy, such as a washing machine or a car. We will also look at conversion efficiency, which is the efficiency of converting energy from one form to another. We will start with the latter. In all energy conversion processes, we have energy as an input, but also useful energy as an output. For example, we may have chemical energy in the form of coal as an input, and then, through a coal-fired power plant, we produce electrical energy as output. The energy conversion efficiency is then defined as the useful energy output of the conversion divided by the total input energy. In our example, this would be the electrical energy output divided by the total energy content of the coal. This is a useful measure in many applications. But we also encounter situations in which there is no energy output. These cases are especially relevant for the end-use side of the energy system. Here, energy is used to provide useful functions like a comfortable home or the production of steel. These outputs cannot be measured in energy terms. We therefore need another indicator of energy efficiency for these applications. We call this indicator the specific energy consumption. It is the energy use per unit of activity. The exact definition depends very much on the activity. If, for example, you want to heat an office, you measure the specific energy consumption as the amount of energy required to heat a unit of office area. In this case then, the unit is megajoule per square meter. Alternatively, in the case of steel making, you measure specific energy consumption as megajoules needed per ton of steel produced. One important remark: you can easily see from both definitions that it is better if the energy conversion efficiency is higher. In the case of specific energy consumption, it is better if the value is lower. So then we get to our actual topic. What is energy efficiency improvement? It can simply be defined as a reduction of the specific energy consumption. So it can mean heating a certain home with less energy, driving a number of kilometers in your car with less energy, or producing steel with less energy. This is energy efficiency improvement. And I want to emphasize that energy efficiency improvement is not something new. One of the most striking examples of this is the energy that is needed for lighting. Here we talk about the conversion efficiency of lamps from energy to light. Candles or oil lamps had a very low energy efficiency. Gas lamps were already a bit better, but a big leap was made when the incandescent lamp was invented. This was already about 100 times better than the traditional candle. Later, there came the compact fluorescent lamps, which provided further efficiency gains. And nowadays, we have LEDs, which are more efficient still. You see that over the course of a few hundred years, the energy conversion efficiency of lamps has increased by a factor of 1,000. Here I show you an example of the improvements in specific energy consumption over the past century. This particular case concerns the developments of iron production out of iron ore. We see that it has reduced by a factor of about 20 over the past 200 years. You see there is a gradual improvement of the energy efficiency shown as a reduction in the specific energy consumption as a result of incremental and radical improvements to the production process. So this is another example to recognize that energy efficiency improvements are always occurring. In the framework of climate policy and climate mitigation, we talk about enhancing the rate of energy efficiency improvement. The emphasis so far was very much on energy efficiency improvement, and that is indeed critical. But it is important to note that there are various other ways to limit energy use. One method is to do things in a different way. For example, modal shift in transport, moving from passenger cars to public transport. Another method is circular material use. When you use materials in a more efficient way or recycle them more, you avoid the energy-intensive production of primary materials. On top of that, you can also reduce the activity. For instance, you can fly less or less far, or you can reduce your thermostat settings by 1 or 2 degrees. But let us get back to energy efficiency improvement. How can we improve the efficiency? Basically, there are 3 major ways to do this. The first one is to reduce losses of energy. For example, to reduce the heat losses through surfaces or improve the aerodynamics of a car. The second is to recover energy to use it again. For example, by using waste heat flows from industrial processes to preheat the incoming flows. And the third is to have more efficient conversion. In the additional material, you will find more information on this, and you will see there are a vast array of options to improve energy efficiency. This diversity makes the field very complex. It's very difficult to oversee them all. But the combination of all these technologies and practices certainly has the potential to play a very important role in climate mitigation strategies.